Hi guys, I'm back with my lectures. Still on introduction to molecular and empirical formula, and we've done calculations on empirical formula on how to calculate the empirical formula of a compound given the masses or the percentage composition by masses. And I strongly believe we've done justice to that. So today we want to look at calculation of what molecular formula. How we can calculate the molecular formula. Calculations involving what molecular what formula. Calculate the molecular formula of what a compound. Calculations on what on molecular formula. How we can calculate the molecular formula of what of a compound. To calculate the molecular formula of the compound, you need the empirical formula, of which you've done it. You need the molar mass, that's the relative molecular mass of the compound. So, these are the basic requirements that is needed to calculate the molecular formula. I repeat, you need the empirical formula of the organic compound or any other compound. You need the molecular formula, the molecular mass of that particular compound. So the two basic things you need to calculate what the molecular formula. And from our previous class, we are meant to understand that the molecular formula, it shows what the actual number of atoms of each of the elements that is present in that molecule. So now let's go straight to question without wasting much time. What we have here, this is a typical example. We said a compound has the empirical formula CH2O and a molar mass 180 gram per mole. What is its molecular formula? So you're asked to calculate the molecular formula here to determine the molecular formula. So the basic requirements are here. You need what? The empirical formula of the organic compound and the molar mass of that compound, the relative molecular mass of the molar mass of that compound. So I'm going to be using two methods. I'm going to use two methods to solve this particular question. And at the end of the day, we'll get the same answer. So irrespective of the method. So please, you are free to choose any method you are very, very comfortable with. At the end of the day, you arrive at the same answer. Now, let me start with the first method. I'm going to give you a formula. The formula is molecular formula. Please, I want you to put it down. Molecular formula is equal to the molar mass over what? Empirical formula mass multiplied by the what? Empirical formula. So you can write it down. Let me put it again. Molecular formula is equal to what? The molar mass over what? Empirical formula mass times what? The empirical formula. So you can write it down. The molar mass of the empirical formula mass. So we're talking about the molar mass of the empirical formula, which is the empirical formula mass multiplied by the empirical formula. With this formula, you can solve any question that has to do with what? Molecular formula. When you want to calculate the molecular formula of a compound or in the molecule. Once you know the molar mass divided by empirical formula mass times the empirical formula. Now let's apply this formula. Please, I want us to listen attentively so you get the best out of this class. So, having written down the formula, now let's apply the formula in solving this particular question. So what do we have here? We have the empirical formula. It's equal to CH2O. You have the molar mass 180. So all we need is the empirical formula what mass of which we are going to calculate. So since we know that the formula is CH2O, so to calculate the empirical formula mass will be equal carbon is 12 plus hydrogen is 2 bracket 1 plus 16. The relative atomic mass of carbon is 12, hydrogen is 1, 2 times 1 plus 16 with the relative atomic mass of oxygen. So let me use my calculator. That means we have 12 plus 2, that is 14, then plus 16, which is equal to 30. So to calculate the molecular formula, so having gotten all the parameters, so molecular formula will be equal to the molar mass. What is the molar mass? 180 over the empirical formula mass, which is 30 times the empirical formula, which is CH2. This cancel this. 3 here, 1, 3 here, 6. So the molecular formula will be equal to what? 6 times what? CH2, which will now be equal to what? 6 H12 O6. This is the molecular formula that gives us the actual number of what? Each of the atoms that is present in the compound or in the molecule. So it's as simple as ABC, just to apply the formula. Straightforward, as simple as ABC. So this is the first method. I'm going to approach it using another method. Whichever method you choose to use, you still arrive at the same answer. So that's it. That's just it. Now let's go to the next method. Okay. Still on the same question. Want to use another method. Okay. What we're going to do here now is, since we already have the empirical formula, CH2O, and the molar mass is what? 180 gram per mole. So it will be empirical formula mass. No, it will be empirical formula bracket N is equal to the molar mass. So what is the empirical formula? CH2O bracket N is equal to 180 as the molar mass. So let's calculate the empirical formula mass, which is 12 plus 2 bracket 1 plus 16 bracket N is equal to 180. So 12 plus 2 plus 16 is what? 30. N is equal to what? 180. So if 30N is equal to 180, divide both sides by 30, divide both sides by 30 to get N. N now will be equal to what? 6. Therefore, empirical formula, therefore, the molecular formula will be equal to what? CH2O bracket 6, which will now be equal to 6 times the empirical formula, which will now be 6 is H12 O6. As simple as ABC. So it's the same method you have to use. So the empirical formula is what? 6 is H12 O6. So it depends on the formula you want to use. Since you're getting the number of N now, you just multiply N by the empirical formula, which is 6 is H12 O6. So that is it. So you can see it's as simple as ABC. All you just need to do is to attempt as many questions as possible so that you get used or get conversant with the entire process. Just apply the formula, follow the principle, apply the formula, and feel free to reach out to me for any difficulty or any challenge. I'm always there for you. Now let's take another example without wasting much time. And if okay, yes, this is another example. A liquid Y of molar mass 44 contain 54.5% carbon, 36.4% oxygen, and 9.1% hydrogen. A. Calculate the empirical formula of Y. B. Deduce its molar mass. So the first thing we are going to do is to calculate the empirical formula. So we have the molar mass. We have the percentage composition by mass. So we have to calculate the empirical formula so we can calculate the molecular formula. So carbon is 54.5, hydrogen 36.4, oxygen is 36.4, and then hydrogen is 9.1. So sorry about that, 9.1%. So carbon is 54.5, hydrogen is 9.1%, and oxygen is 36.4. So the organic compound contain carbon, hydrogen, and what? Oxygen. So from our previous class, I've explained in detail how you can calculate the empirical formula. So after getting the percentage composition by mass, you get the number of moles. So divide through using what? The relative atomic mass of each of the elements. So divided, you have to divide by the relative atomic mass of each of the elements. So carbon is 12, hydrogen is 1, and oxygen is 16. So you have 54.5 divided by 12, you get 4.54, 9.1, then 36.4 divided by 16, so 2.28. Okay, so the next step, these are the moles, so you divide by the smallest, divide through by the smallest. So what is the smallest here? 2.28. So divided by 2.28, divided by 2.28, divided by 2.28. So to get the mole ratio, these are the moles, you get the simplest ratio. So you know the empirical formula shows the simplest what? Ratio of each of the atoms or elements that are what? Present. The simplest whole number ratio. It shows the simplest whole number ratio. So we're going to express it with the simplest what? Whole number ratio. So using my calculator, 4.54 by 2.28, you have 1.9, which is approximately 2. Then 9.1 divided by 2.28, which is 3.9, approximately 4. Then 2.2 divided by 2.28, which is 1. So the empirical formula is equal to what? Empirical formula is equal to C2, 2 atoms of carbon, H4, 4 atoms of what? Hydrogen, and 1 atom of oxygen. So this is the empirical formula. So we've gotten the empirical formula, which shows the simplest whole number ratio of each of the elements that is present. So this is the simplest whole number ratio, 2 ratio 2 ratio. First, you can see there is no common factor here. The common factor here is just 1. So this is the simplest form. Now let's go to B, which is the what? Molecular formula. So we're going to apply the formula. Molecular formula is equal to what? Molar mass over what? Empirical formula mass times empirical formula. So we already have our molar mass. Our molar mass is what? 44. of our empirical formula mass. So let's calculate the empirical mass. Carbon is 12, which is 2 times 12, 36, plus hydrogen 4 times 1 is equals to 4, then plus 16. So empirical formula mass is 44 times the empirical formula, which is C2H4O. So 4 cancel out, you have 1. So it will be 1 times 1, C2H4. So the molecular formula is equal to C2H4O. So you can see that the molecular formula and the empirical formula are the same. So as you can see, it's as simple as ABC. Thank you very much for listening. I believe you've learned one or two things. Please try and attempt questions. Solve as many questions as possible. And please feel free to reach out to me for any challenge or any difficulty. It's as simple as ABC. I believe you're up to the task and you can solve as many questions as possible. And I strongly believe that I've done justice to empirical and molecular formula. Please attempt as many questions as possible. Please go to my YouTube channel, subscribe to my YouTube channel, go to the comment section, comment. And if you encounter any difficulty, please feel free to reach out to me. I'm always there for you. Once more, I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Thank you very much. Have a nice day. Bye. Thank you.